You ever look up at a massive skyscraper and just wonder, what is holding all of that together? Well, it's not just some random rock and goo. There's actually a hidden language, a kind of secret recipe that engineers and builders use every single day. And today, we're going to decode it.
So what is the secret recipe for a skyscraper? Or a giant dam? Or hey, even the foundation that your own house is sitting on? You know, it seems like it would be impossibly complex. But the answer? Well, it's actually surprisingly simple.
Yep, it all comes down to the mix. It's kind of like baking, right? The final product is only ever as good as its ingredients, and crucially, the proportions you use. In construction, that final product has to be absolutely perfect, because people's lives literally depend on it.
Okay, let's dive right into this. To understand the recipe, we've got to know the ingredients first. And there are 4 fundamental building blocks that make up pretty much all the concrete in our modern world.
First up, you've got cement. Think of this as the binder. It's the glue that holds the whole thing together. Then you've got your aggregates. Sand is what we call the fine aggregate. It fills in all the tiny gaps. Then there's gravel or crushed stone. That's your coarse aggregate, and it gives the concrete its bulk and a lot of its strength. And finally, of course, water. Water's the activator. It kicks off a chemical reaction with the cement that makes the whole mixture harden.
Now here's where it gets really interesting. You can have all the right ingredients, but if you don't get the proportions exactly right, you're in for a world of trouble. This is the absolute core secret to concrete strength. Let's go back to that cake analogy. If you're baking and you accidentally use 10 times too much flour, you don't get a cake, right? You get a hard, useless brick. Well, in construction, that kind of disaster isn't just a bad dessert, it's a potential structural failure. The ratio, it's everything.
And here is that secret recipe in action. Take a look. For what's called an M20 grade mix, you'd use 1 part cement to 1.5 parts sand and 3 parts aggregate. But watch what happens for the stronger M25 grade. The ratio changes. Now it's 1 part sand and only 2 parts aggregate. This might seem like a small change, but it dramatically increases the concrete's strength because it makes the mix much richer in that all-important cement binder.
So you've probably seen these codes before. M20, M25, maybe on a bag of cement at the hardware store or on a construction plan. They look like technical jargon, but once you know the secret, they're actually a really clear and simple code. So let's break it down.
The entire grading system is built around one key concept: compressive strength. It sounds technical, but it's simple. It's just a measure of how much squeezing force a block of concrete can handle before it cracks or breaks. It is the ultimate test of its toughness.
So let's decode M20 together. The M, that just stands for mix. Easy enough. The number 20, that's the really important part. It means that after curing for 28 days, which is the industry standard time for concrete to get to its full design strength, that little block can withstand a minimum force of 20 newtons on every single square millimeter of its surface. It's a simple universal code that tells you exactly how strong it is.
Okay, so that's the science. Pretty cool, right? But now let's see how this actually builds our world. How do these numbers translate from a lab test into the sidewalks, bridges, and buildings we use every single day?
Well, as you can probably guess, as that grade number goes up, from M15 to M20 to M25, the strength increases significantly. You can see it right here. This lets engineers pick the exact right strength for the job, so they're not wasting materials by making something too strong, or, way more importantly, risking safety by making it too weak.
And here's where it all really clicks. A lower strength grade like M15, that's perfect for things like pavement or curbstones. M20 is the real workhorse for residential construction. We're talking your home's foundation, your floors, your driveway. But when you need to support a massive high-rise building, you need the serious strength of M25, or even higher for those critical columns and beams. It's all about using the right grade for the right job.
So let's bring this all home. Why do we go through all this trouble with grades and mixes and ratios? It's about creating a predictable, reliable, and above all, a safe system for building the world around us.
When you really think about it, it all comes down to this. That tiny difference, 1 extra part of sand or 1 less part of gravel, that is the razor-thin margin between a foundation that will last for centuries and one that could potentially fail. In construction, precision isn't just a nice-to-have. It's the only thing that separates strength from weakness.
So if there's one thing to take away from all this, it's that concrete grades aren't just jargon. They are a universal language.
It's a language understood by builders and engineers all over the globe, and it ensures that a skyscraper in Dubai and a bridge in San Francisco are both built to the exact same high standards of safety and durability.
At the end of the day, our entire world is built on these kinds of carefully crafted recipes, from the microchips in our phones to the concrete in our cities. And it really makes you wonder, doesn't it? With all the new materials and new challenges on the horizon, what incredible new recipes are we going to invent to build the world of tomorrow?